Welcome to Study Loop.
This is the answer to Chapter 16, problem number 65 from the Smith Organic Chemistry textbook. And this problem says treatment of isoprene with one equivalent of mCPBA forms A as the major product. We're given some spectral information about A, and then we're asked to come up with the structure of A. And so I'm actually not even going to consider the IR or the mass spectrum because they don't really tell us much that we don't already know. The NMR is going to be really what we need in order to solve this problem. And hopefully you know by now that treatment of an alkene with mCPBA is going to give an epoxide. And so our product is going to be one of these double bonds is going to be epoxidized. And so the only question that's left is really which double bond is it that will be epoxidized? And so we can figure that out using the NMR data that we have. And so the first signal, the 1.5 ppm singlet that integrates to 3. So that's going to be a methyl group. The signal at 2.8 ppm, that's 2 doublets, is going to be a CH2. And it's hard to really say what kind of environment that's going to be in. So we'll just leave that as a CH2 for now. And then our last two signals are down at 5.3 ppm and 5.6 ppm. So the first one at roughly 5.3 ppm is a doublet of doublets. So it's actually 2 doublet of doublets. And so because of the chemical shift, I'm going to say that this is 2 alkene hydrogens. And then the last signal is going to be 1 alkene hydrogen. Okay, and so taken together, these two signals make me think of something like this. So where we have the rest of the molecule there, and then we have an alkene, and then we have one hydrogen here and 2 hydrogens here. And so this is what these last two signals are telling us. And in order for that to be the case, it has to be the first double bond looking from left to right in the starting material that gets epoxidized. So we have to be talking about this. Okay. And we can just sort of double check. So our first signal, this methyl group, is going to be here. Our second signal, we said was a CH2, and we didn't know really what environment it was in. And so this actually does make some sense when we look at this now. They're downshifted because they're on a carbon that is attached to an oxygen. So it makes sense that they would be shifted downfield. And then again, the alkene protons. So this first signal that I'm blue arrowing is going to be these 2 protons. And then the last signal, I'll do a green arrow. That's going to be this proton. And so that does make sense. And I think that this is the right answer. So I'll redraw it. So this is going to be our product. And again, this one was kind of easy because we should know that when we treat an alkene with mCPBA, we're going to get an epoxide. So we knew that one of these double bonds would have to be epoxidized. And then we just need to use the NMR data to figure out which double bond it's going to be. And because we get those two different signals for alkene protons, and because there are three alkene protons, we know that it has to be that first double bond that gets epoxidized. Because if the other double bond were to be epoxidized, we would only get one alkene signal, and it would be for the two protons on the other double bond. Okay, so that's our answer here. This is molecule A, and that's the answer to chapter 16, problem number 65.